Hello friends, I am Antika and in this video I am going to discuss about the reproduction and the life cycle of Marsilia. In an earlier video, I have discussed an overview of Marsilia, its external as well as internal structure, the transverse section of various parts, the anatomy of Marsilia, and also the economic importance, the control measures when Marsilia turns woody, and the fossil of Marsilia. And in this video, I am going to discuss about the reproduction and the life cycle of Marsilia. So let's start the video. Now we come to the reproductive cycle, and it grows very commonly. This tuber, which is actually a modification of the rhizome, it is found to be growing at the apical region of the growing rhizome. They at the end of the growing season, they absorb high amount, they actually store high amount of reserve food matter and gets covered with scales and act as perinating organ. They perinate during the dry season, and on return of favorable condition they form a new plant, thus vegetative tubers. Then we come to the reproduction, the spore bearing organ. It is the sporocarp. Here in this picture we see that these are the sporocarp that is born in the base of the stalk or pedicel of the leaf, the sporocarp. They are here. We see this sporocarp is greenish color because it is young, but this green color, they turn dark brown when it matures. And this ellipsoidal or kidney shaped sporocarp, it is covered with hair and it is attached to the petiole or the stalk of the leaf. And this this sporocarp, it is actually a perinating organ. It can act as a perinating organ if there is a high amount of water. Then it absorbs water and matures, and the process continues. But however, if there is scarcity of water, say for example in drought condition, then this porocarp it acts as a perinating organ. It remains dormant, and even after 100 years, if after 100 years the sporocarp gets in contact with water, then it regains its growth and starts germinating. So this is a sporocarp. This sporocarps, they are the perinating organ. They can perinate, and the viability can be even 100 years. So after they get suitable condition, they start germinating. So the sporocarp, once the condition is dry enough, it is dispersed by air. But if this sporocarp is lying in water condition, then they can also be dispersed by water fowl, that is the water birds. So what happens is that the sporocarp, it has got a very thick outer covering, very protective outer covering that protects it from desiccation. But when in contact with water, it absorbs water. The inner layer, that is this is the sporocarp, and this is the layer with the sori. The sori are born here. So this outer to the sorus layer, this layer of inner cortex, that is the hourglass cell that I mentioned. The hourglass cells, they what they do is they absorb water and they disintegrate, turning mucilaginous. So this mucilaginous mass or the gelatinous mass inside the sori, inside the sporocarp, this entire gelatinous mass, it swells. and it creates a pressure on the outer wall. So this outer wall of the sporocarp, it actually burst, and the microsporangium and megasporangium, they come out. Once they come out, they start germinating. So the microsporangium, megasporangium do not germinate when inside the sporocarp, but they germinate after they come out. So dehiscence of the sporocarp. So the inner gelatinous mass, it puts a pressure on the wall of the sporocarp, and the sporocarp, it here we see it already, it dehisces into two halves, and the inner mass is coming out, that is the sporophore with all the attached sori. They come out in a looped fashion. First in a looped fashion they come out. Here we see now gradually it straighten up, and in this diagram E we see that the sporocarp containing the sori, they are straightening out, and each of this sori, they contain one megasporangium and two microsporangium. That is the microsporangium or the male gametophyte, and the megasporangium, that is the female one. Here we see that the gametophyte, it is much reduced. They do not form a different gametophytic generation is not that much dominant. So inside this, each of the sori will start germinating the megasporangium and the microsporangium after it gets liberated, after it comes out from the sporocarp. Gametophyte generation. Now after the sporocarp, it dehisces into two halves. The sporophore containing the sori comes out. The sori starts developing. Now the sori contains one megagametophyte and two microgametophyte, that is a male gametophyte. The male the megagametophyte, it is megaspore, and the male gametophyte is the microspore. Note that in Marsilia or water fern, we see that the gametophytic generation is limited to the spore and gamete. So this microspore or the male gametophyte, it is yellow colored and it is globose in shape, and at the apical region they have a triradiate ridge. The entire spore, microspore, has an outer layer, very thick outer layer, exine or exosporium, which has got much ornamentations, and the inner to the exosporium is the endosporium or the intine, that is quite thin. And once the sori comes out of the sporocarp, the microspore, what it does is it absorbs water and increases in size, and whatever food matter, that is the starch grain that is stored inside the microspore, they start to lie in the in the peripheral position, and all the nucleus nuclear matter, that is a nucleus, they lie in the center. So after this shifting of the nucleus to the center and the starch grain to the peripheral region, there occurs an unequal division, where the entire microspore, it is divided in a very small lenticular or lens-shaped male prothallal cell and a very large apical cell. Now this large apical cell, they do not have any further function in the development. They actually has a nutritive function. So this lenticular cell, it undergoes division to form two antheridial initials, and each of these antheridial initial cell, they develop a antheridium and later a multiflagellate spermatozoid. And here in this picture we see the multiflagellate spermatozoid is formed, ultimate gametophytic structure, the gamete, that is the multiflagellate sperm. The macrogametophyte, the macrogametophyte or the female gametophyte is also has two layer, that is the outer layer or the exosporium and the inner layer in intine or in the endosporium, and these two protective layers are present. The exine or the exosporium has got, in turn it can be divided into 5 layers, the outermost of which is gelatinous and of equal thickness. This one here we see that the outer layer is gelatinous of equal thickness, the middle gelatinous layer and the inner gelatinous layer. So they have a 3 layer of gelatin followed by a prismatic layer, here we see, and a reticulate layer, this one, and the intine the endosporium. So 5 layer of exine and 1 layer of intine that protects the megasporium, and the megaspore also similarly divide into unequal division into a very small prothelial cell and a large basal cell. The prothelial cell, it actually divides many times to form the archisporium. Now the archegonium, it is formed of 2 neck canal cell, 1 ventral canal cell and 1 egg cell. Now what the neck canal cell, the 2 neck canal cell at maturity, they usually gelatinize along with the ventral cell. So this 2 neck canal cell as well as the ventral canal cell, they gelatinize into a mucilage, which is a attractant for the sperm, and this is the egg cell. So once the multi-flagellated sperm are formed, they usually they swim towards the archegonium, and the attracted by the mucilage that is secreted by the archegonium, the sperm, they swim towards the venter, neck and venter, and ultimately they fertilize with the egg cell that is present inside the venter, and once the sperm, they penetrate the egg, one sperm and penetrate the egg of the megasporium, fuses with it, and zygote is formed. So once the zygote is formed inside here, once the zygote is formed inside the megaspore, after fertilization zygote is formed, there is no period of dormancy, there is no resting period. So zygote divides and redivides to form this sporophyte, and the cell of the zygote, it undergoes division to form the epibasal and the hypobasal cell, the epi and the hypobasal cell. So this hypobasal cell, it in turn forms the root and the foot. So the hypobasal cell, it divides again to form the root and the foot. So, and the epibasal cell, this one epibasal cell, it again divide to form the cotyledon and the stem. So the zygote divides into epibasal and hypobasal cell. The hypobasal cell, it forms the root and the foot, and the epibasal cell, it forms the the stem and the cotyledon. So within 24 hours, this type of structure is seen. We see that this is the leaf coming out, and the root, the rhizoids, they are coming out, and this entire zygote that is developing inside the megaspore, it is the ventral region, it converts into a protective calyptra. This is the calyptra. This entire structure, this entire covering, protective covering, is a calyptra, and this region is the foot region of the sporophyte. In transverse section we see this one. This is the transverse section of the sporophyte, young sporophyte. This is the foot region, and the rhizoids, the primary root, they are coming out. And this one is the apical region of the prothallus, where this is the first leaf region. And we see that entire sporophyte, it is covered by this protective tissue, that is the calyptra, that is formed in the ventral region of the. So this is the diagram of the life cycle. Now we start with the mature this stage, the mature Marsilia plant, which develops at the base of the petiole stalk. They have this sporocarp, which contains the sori, and each of the sori has got spore in them, the megasporangium and the microsporangium. So inside the sori, this mega and the microsporangium are present, and this we see that the sporocarp, this one, the sporocarp here, it the inner mucilaginous mass swells, and the sporophore with the sori, it comes out once outside. Each of the sori, they start developing the male and the female gametophyte. This is the female gametophyte. You see two neck canal cell, one ventral canal cell, and this one is the egg cell. And the upper three cell, that is the two neck canal and ventral canal cell, what they do is they disintegrate, and this sperm, multi-flagellated sperm, they fuse with the gamete. Here the fusion process is seen in K, and once fusion is done, the gamete, the sporophyte is formed without any delay. In this stage we see this is the sporophyte, this diagram, and this is how the sporophyte, the first leaf, it is piercing the calyptra and coming out. So this is how pretty much the life cycle. And in this life cycle, this is the gametophytic stage, and this entire stage is the sporophytic. The reduction division, it occurs here. This is the haploid stage, or the gametophytic stage here, and this entire is the sporophytic stage. So this was all about the reproduction and the life cycle of Marsilia. And I've also made a video about the overview of Marsilia, external structure of Marsilia, as well as the transverse section of Marsilia, how the internal structures look, the economic importance, the control measures for Marsilia, as well as a fossil form. In case you haven't watched that video, I will request you to watch that video first, because then there will be a continuity and you'll understand this video better. And the link to that earlier video I have put in the description. And also as I have started the pteridophyte series, I will also be discussing about Salvinia, Adiantum, Pteris, Alsophylla, Lygodium and Glechnia for now, and I will be soon coming up with these videos. Also, as I have started the pteridophyte series, just to give an overview of pteridophyte, I have made a video pteridophyte where I discuss about various aspects, the introductory aspects of pteridophyte. right? And also link to the video I have put in the description box. So comment on the video which portion you want me to discuss more, or any other how you like the video in the comment section. Write it in the comment section. And if you like this video, do hit the like button and share this video with your friends, and also do subscribe to my channel, because your subscription, it encourages me to make more videos. And thanks for watching this video.